welcome to Vidyanagar online science class. Today I am going to discuss with you the second chemistry chapter, Is Matter Around Us Pure? At the end of today's module, you will learn about pure substance, mixture, different types of mixture, solution, suspension, colloids and their properties. Let's move to our today's class. Okay, how do we judge the ghee, milk, butter, etc. available outside pure? Have you ever noticed the word pure written on the packets of consumables? For a common person, pure means no adulteration. But for the scientist, pure substance means whether it is made up of a single particle or not. So pure substance means it's a substance which contains single type of particles. If a substance contains single particles, we can consider them as a pure substance. So a pure substance contains single type of particles. A pure substance which consists of single particles. They are pure. A pure substance consists of single type of particles. They are pure substance. Then what is a mixture? Mixture is constituted by two or more single particles, or mixture is constituted by two or more pure substances. Mixture is constituted by two or more pure form of matter. That is mixture. Pure substance consists of a single type of particles, but mixture consists of two or more pure form of matter. And we can classify mixture into two: homogeneous mixture and heterogeneous mixture. There are two classifications for mixture: homogeneous mixture and heterogeneous mixture. What is homogeneous mixture? Homo means same. If a mixture contains same composition everywhere, such type of mixtures are known as homogeneous mixture. If a mixture contains same type of composition or same composition everywhere, such mixture is known as homogeneous mixtures. Homogeneous mixtures are the mixtures which contain uniform composition everywhere. Uniform composition everywhere. For example, salt solution or sugar solution. If we test salt or sugar solution, if we taste salt or sugar solution, we will get the same taste everywhere. We get only the taste of sugar or salt. Why? Because that mixture contains only salt particles. Same composition everywhere or uniform composition everywhere. Such mixtures are known as homogeneous mixtures. Homogeneous mixture is the mixture which contains uniform composition everywhere. If we taste the sugar solution or salt solution, we get same taste or sugar or salt taste. Such mixtures are homogeneous mixtures, uniform composition everywhere. For example, if we make a mixtures using different amount of salt or sugar, means you have to make a mixture and which mixtures with different amount of salt and sugar, and the amount of salt and sugar in different rate. So after mixing the solution, if we test the mixture, you get different tastes. In some areas you may get more sweet taste, or in some areas you may get more salt. That means different or non-uniform composition, different taste. There is no uniformity for that solution. Such mixtures are known as heterogeneous mixtures. If a solution contains non-uniform composition everywhere, such mixtures are known as heterogeneous mixtures. If we get only same taste, that is homogeneous. If we get different taste, that different taste is non-uniform composition. If a mixture contains non-uniform composition, such mixtures are known as heterogeneous mixtures. So we can classify mixtures into two: homogeneous mixtures and heterogeneous mixtures. Homogeneous mixture is a mixture which contains uniform composition everywhere, and heterogeneous mixture is a mixture which contains non-uniform composition everywhere. Okay, then what is a solution then? What is a solution? We are using the term solutions everywhere, no? So what is a solution? How we define a solution? Solution is a homogeneous mixture of two or more substances. Solution is a homogeneous mixture of two or more substances. Solution is an example of homogeneous mixture because same composition everywhere. So, solution is a homogeneous mixture of two or more components. What is solution? Solution is a homogeneous mixture of two or more components. And the components present in the solution are solute and solvent. Which are the components present in the solution? Solute and solvent. Solute plus solvent is a solution. A solution contains a solute and solvent. There are two components in a solution, solute and solvent. For example, you see sugar solution. In sugar solution, two components you can see, right? Sugar and water. Which are the two components? Sugar and water. So, the two components present in a solution is solute and solvent. Solute is the component present in less amount. Solute is the component present in less amount and solvent is the component present in higher amount. In that case, in sugar solution, sugar is the solute and water is the solvent. While we making the sugar solution, we add little amount of sugar and more amount of water, right? So, solute is the component present in lesser amount. Solute is the component present in lesser amount. So, sugar is the solute and water is the solvent in sugar solution. In salt solution, salt is the solute and water is the solvent. So, solution is a homogeneous mixture of two or more components and the main component in solution are solute and solvent. Solute is the component present in lesser amount and solvent is the component present in higher amount. For example, tincture iodine. In tincture iodine, have you heard about tincture iodine? Tincture iodine is an antiseptic which we can use to cure our wounds. In order to cure our wound, you can use this tincture iodine as an antiseptic, right? So, tincture iodine means iodine in alcohol. Which is that mixture? Iodine in alcohol. Iodine in less amount and alcohol in higher amount. So, iodine is the solute and alcohol is the solvent. And soda water. Soda water. What is soda water? Soda water means carbon dioxide in water. Soda water is a mixture which contains carbon dioxide and water. So, carbon dioxide is a lesser amount. So, carbon dioxide solute and water is the solvent. And in sugar solution, sugar is the solute and the water is the solvent. So, solution is a homogeneous mixture of two or more components and the components are solute and solvent. Solute is the component present in lesser amount and solvent is the component present in higher amount. And we discussed the examples also. Okay, now we are going to discuss about the properties of solution, suspension and colloid. Solution, suspension and colloid. What is solutions we discuss now? So the remaining things only. So suspension and colloid. See example for suspension, chalk powder in water. Example for suspension, chalk powder in water. After adding chalk powder in water, if you stir it thoroughly, and if you keep this solution undisturbed for some time, you can see that chalk powder settles down and water comes up. So, suspension is a heterogeneous mixture. Suspension is an heterogeneous mixture and in suspension, solute particles settles down at the bottom of the beaker. See, chalk powder and water. Chalk is the solute particles and water is the solvent. So, when we keep this solution undisturbed for some time, solute particles settles down at the bottom of the beaker and water comes up. So, solution is a mixture which contains solute particles and solvent, and these solute particles are settles down and solvent particles comes up. So, such mixture is known as suspension. Suspension is an example of heterogeneous mixture. Suspension is an example of heterogeneous mixture. In suspension, solute particles settle down and the solvent particles are at the topper layer. And what about colloid? Colloid, the best example for colloid is milk. Milk, right? Milk looks like, the colloids looks like homogeneous. It looks like homogeneous, but it is heterogeneous. When we see the milk, we see every composition is same, but actually it is not like. So, colloids looks like, colloidal mixtures are, or colloidal solutions look like homogeneous, but actually they are heterogeneous. Look like homogeneous, but heterogeneous. So, solution is a homogeneous mixture, contains 2 or more components, and suspension is an heterogeneous mixture, and solute particles settle at the bottom of the beaker, and colloidal solution, it looks like homogeneous, but it is heterogeneous. We discussed about the solution, suspension and colloid. Right. What is a solution? A solution is a homogeneous mixture of 2 or more components. A solution is a homogeneous mixture of 2 or more components. And which are the components in a solution? There are solute and solvent in a solution. Solute is the component present in lesser amount and solvent is the component present in higher amount. Right. Okay. Look at here. 1 glass of water you can see in my hand, right? So this is not a water, this is salt water. I added 2 spoonful of salt into this solution. So tell me, which are the solute and solvent? Which is the component present in lesser amount in the solution? Yes, it is salt. So salt is the solute and water is the solvent. Salt is the solute and water is the solvent. And you see how it looks like? It looks like, water, right? It looks like the water. It is clear and transparent. When you test the salt solution from any part of the solution, you will get the same taste, which means uniform composition. Uniform composition. So, solution is a homogeneous mixture. And what about, can you see any particle inside this? Okay, we will discuss about the comparison between the solution, suspension and colloid in the coming next section. But before that, just you understand this. Can you see the particles inside the solution? No, the water, if the solution looks like a water, there is no any particles. That means solution is a homogeneous mixture. Okay, then, so the second one is suspension. Second one is suspension. What is suspension? Suspension is a heterogeneous mixture. You see, you can see mud water in my hand, right? So this is mud water, right? So, solution is it homogeneous or heterogeneous? So, suspension is a heterogeneous mixture. Suspension is a heterogeneous mixture. Why? Because variable composition inside the solution. Variable composition you can see in it, inside it, right? Variable, different composition. In some areas you can see more mud and in some areas less mud. That means different composition inside. So it is an example of heterogeneous mixture. And is the mud particles are dissolving in the solution? No. These mud particles are the, which is the solute here? Mud is the solute and water is the solvent. So mud particles settle in the bottom of the container. It is not mixes with the water or it does not dissolve in water. It settles at the bottom of the container. So this is a heterogeneous mixture. And what about the particle size? You can see the mud particle inside it, right? So the particle size of mud particles are bigger in suspension. And what about the third case? Third case is colloid. See, this is an example of colloid. This is rice water. I told you milk also example of colloid. Milk also example of colloid, but this is a rice water, right? This water, when we mix this rice water, you can see it looks like homogeneous. The solution looks like homogeneous, but it is not homogeneous. It is a heterogeneous mixture. When you see this rice water, you will feel the composition is same everywhere, but the composition is not same, so it's an example of heterogeneous mixture. Colloid is an example of heterogeneous mixture. And what about the particle size? The particles cannot see because they are very small. So colloid is an example of heterogeneous mixture, but it looks like homogeneous, but it is a heterogeneous mixture. Okay. So solution is a homogeneous mixture, and the components of solution are solute and solvent, and solute is the component present in lesser amount and solvent is the component present in higher amount, and suspension is a heterogeneous mixture and colloid is a heterogeneous mixture, but colloids looks like homogeneous but they are heterogeneous. Concentration of a solution. Based on the amount of solute present in a solution, we can classify them into diluted, concentrated and saturated solutions. So they are diluted solutions, concentrated solutions and saturated solutions. Diluted solutions are the solutions which contains less amount of solute. Diluted solutions contain less amount of solute and the balance one is water. For example, if a solution contains 10% solute, 90% water. If there is 10% solute, 90% water. So that is diluted solution. Diluted solutions contain less amount of solute. And concentrated solutions contains more amount of solute as compared to the solvent. Concentrated solutions contains more solute particles as compared to the solvent. Okay, I'll show you. You can see two color solutions in my hand. You can see two color solutions in my can. Can you see any difference of these solutions? Both the solutions contain same color. Definitely white color. What about the intensity, or if there is any difference? Is this solution is more color or is this solution is more color? Definitely the first one, this one is more color, and comparing with this this one and the second color water, their color is less, their intensity of the color is less. Why? Here the solute particles are less and here the solute particles are high. So in which solution more solute? This one. And in which solution solute particles less? This one. So if the solute particles are less, diluted solution. So this is a diluted solution because less amount of solute and remains water. And this is a concentrated solution because more solute plus then remains water. So what is concentrated solutions and diluted solution? If less amount of solute, dilute solutions. If more amount of solute, concentrated solution. So based on the amount of solute present in a solution, we can classify them into diluted and concentrated. So this is the diluted one because less amount of solute, and this is the concentrated one because more amount of solute. Okay, so one is diluted, this is diluted solution because it contains less amount of solute, and this is concentrated solution because this contain more amount of solute. Okay, and the next one is saturated solution. Now we are going to discuss about the saturated solution. Okay, what is saturated solution? For example, if I told you to make a salt solution, if I told you to make a salt solution, what you will do? You will take some water and you have to add salt or sugar into the water. Okay, so 1 glass of water and you have to add salt or sugar into the solution. So that is a way to make the salt solution or sugar solution. Suppose if by mistake if you added 2, or instead of adding 1 or 2 teaspoons of sugar or salt, you by mistake you added 5 or 6 teaspoons full of salt or sugar. What you can see there? Can you dissolve that salt or sugar into the solution? Can you dissolve? You see? You can see in this glass of water I added 8 teaspoons of salt, 8 teaspoons of salt, and you can see that the salt remains settles under the glass because I stirred many times, 10 for 15, I stirred many times, but what is the end results? That salt and sugar remains in the solution. Why? Because you can see I took 1 glass of water, right? This 1 glass of water have some capacity. So this, and you see here I added only 2 teaspoon of salt. Because this is a diluted solution, right? This is a diluted solution. I can add more amount of, I can add, you know, 2 more or 3 more spoonful of salt into this solution, because the amount, the water inside this glass has more space, because I added little salt only into this glass. But what about here? Here I added 8 teaspoon, means the glass of water, the water inside the glass have some space. So by adding more amount of salt, you know, I told you, we discussed in the previous class that there is space between the particles. There is space between the particles. After adding more spoon of salt or sugar, if the solution or if the solute or if the salt or sugar still remains in the solution, means the gaps inside the particles finished, right? Once that gap finished, then we cannot dissolve that salt or sugar into the solution, because the given amount of water have some space. If it finished, then no more dissolving is not possible. But here I added only 2 teaspoon, because little more space is balanced. So till that I can add salt into the glass of water. But what about here? By adding more amount of salt into this glass of water, the space inside the liquid particles finished. Then if I am adding more and more salt into this, I cannot dissolve them in this water. So this is the result, it still stays inside the solution. Why? Because gaps finished, no more gaps, which indicates the given amount of water have some space. Once it overcomes, we cannot add more salt into it, because the available space or the space between the particles completed. In that case, if you are adding more amount of salt or sugar into the solution, the extra salt or sugar still stays in the solution. And you know, let me tell you one more example. You are very much interested to eat biryanis. You are very much fond of biryanis, right? But your stomach have some space. If there is 2 or 4 or 5 plates of biryani with you, can you eat that biryani? No. Why? Because your stomach has some space. Once it overcomes, then if how much tasty food or how much favorite dish, you can't eat, because the saturation point of your stomach reached. So what is saturation level? Saturation is the, in a given temperature, the solution that has dissolved as much as it is capable of dissolving. How much possible for that 1 glass of water, it completely dissolved in it. So saturation level or saturation is the, in a given temperature, the solution that has dissolved as much as it is capable of dissolving. So if the stomach, in case of stomach, how much space inside the stomach, it is already finished. So furthermore, you can't eat the biryanis. Why? Because there is no space in your stomach, because that is, your stomach attained the saturation level. So that is saturation. In a given temperature or in a particular temperature, the solution that has dissolved as much as it is capable of dissolving is known as saturated solution. So when a solution attains the saturation level, then further we cannot dissolve any solute in that solution, because the gaps filled or the gaps completely filled. So that condition is known as saturated. So in a given temperature, the solution that has dissolved as much as it is capable of dissolving is known as saturation. Okay, and what is dilution? Dilution is the solution which contain less amount of solute particles. That is dilution. Okay, then we are going to define what is solubility. Solubility is the amount of solute present in a solution. For example, if 50 gram salt is there or if 50 gram sugar is there, so that 50 gram is the solubility. How much amount of solute dissolved in a solution is known as solubility. How much amount of, the amount of solute dissolved in a given solution is known as solubility. The amount of solute dissolved in a solution is known as solubility. Okay, so what is saturation? The solution that has dissolved as much as it is capable of dissolving. So that is known as saturation. What is saturated? At any particular temperature, the solution that has dissolved as much as it is capable of dissolving is said to be saturated. At any particular temperature, the solution that has dissolved as much as it is capable of dissolving is said to be saturated. Okay, if the amount of solute in a saturated solution is less than the saturation level, it is said to be unsaturated. If the amount of solute dissolved in a solution is less than the saturation level, it is said to be unsaturated. That means some more solute we can dissolve in the unsaturated solution. If the amount of solute present in a solution is less than the saturation level, less than the saturation level means what? Some more gaps remains there, right? So we can add some more, we can add more solute particles to the solution to make the saturated solution. So unsaturated contains little more space, some more space we can add some little more solute into the solution. So such solutions are said to be unsaturated. If the amount of solute in a solution, the amount of solute in a solution is less than the saturation level is said to be unsaturated. For example, you know, we can if there is, in case of stomach, if you eat only less amount of biryani, you can eat little more because little more space in your stomach. That is the case unsaturated. Unsaturated solutions can dissolve some more solute particles to attain the saturation level. So what is saturation? At any particular temperature, the solution that has dissolved as much as it is capable of dissolving is said to be saturated. If the amount of solute in a solution is less than the saturation level, it is said to be unsaturated. As I told you, solution is a homogeneous mixture and two components in the solution are solute and solvent, and suspension is a heterogeneous mixture and solute particles do not mix, they settle down, and colloidal particles, colloidal mixture or colloidal solutions looks like homogeneous but they are heterogeneous, right? So now we are going to discuss about their properties. We are going to compare the properties of suspension, solution and colloids. Okay, so the first comparison is solution is an homogeneous mixture, suspension is a heterogeneous mixture, and colloid looks like homogeneous but they are heterogeneous. And second one, the size of the particles. How the particle size varies in solution, suspension and colloid. For example, you know, sugar solution. In sugar solutions, can you see any particles? That we discussed earlier that when we add sugar or salt into the water, these particles are get into the space between the particles, that is dissolved. Which means the solution or the salt solution or sugar solution looks like clear. That means we cannot see any particles inside the sugar or salt solution. And what about in case of suspension? Example, chalk powder in water. The chalk settles down at the beaker, right? So you can see the chalk powders there, chalk particles there. And what about in case of colloids? In colloid, like milk, can you see any particle inside the milk? The milk, you know, it's a white substance, but can you see any particles inside it? No. That means solution particles are too small and which cannot be seen by our naked eyes. So solutions particles are very small and which is not possible to see with our eyes. And suspension particles are big we can see with our eyes. We can be seen with our eyes. And colloidal particles are also small, which is not possible to see with our eyes. But colloidal particles are not too small like solution particles. So the colloidal particles are between solution and suspension. Solution particles are too small, then suspension particles are big, and colloidal particles are between, the particle sizes between the solution particles and the suspension particles. So, solution particles are too small, cannot be seen with our eyes. Suspension particles are big, so we can see with our eyes. And colloidal particles are also too small, we cannot be seen with our eyes. But the colloidal particles are their particle size between the solution and the suspension. So, that is the second comparison. And the third one, solution particles are not scatter beam of light. Solution particles not scatter beam of light, and suspension particles scatter the beam of light, and colloidal particles also scatter the beam of light. What is the scattering? You know, scattering means you just consider the light strike on a surface and it splits to different sides. The light after striking a surface, it splits to everywhere. So that is a process known as scattering, scatters everywhere. Right? And the solution particles are too small. You know, due to the small size of the solution particles, that means the solution particles does not provide a space or the surface for the light to strike. The light should strike there, then only it scatters. So, the solution particles are too small, or it does not provide a surface for the light to strike on it. If it not strike, there will be no scattering. That's why solution particles do not scatter beam of light. Got it? Why solution particles do not scatter beam of light? Because that particles are very small. There is no much surface to scatter the beam of light. And in case of suspension, you know, suspension particles are big to scatter the beam of light, because that particles we can see with our eyes, and due to the big size, the suspension particles can strike on it and it scatters everywhere. So suspension particles scatter beam of light. And I told you colloidal particles are between solution and suspension, so that particles provide enough space for the light to scatter. So it is not that much small like solution particles. So colloidal particles are big enough to scatter the beam of light. So that's the third point. Solution particles do not scatter the beam of light, and suspension scatter the beam of light, and colloidal particles also scatter the beam of light. Okay, and next one, when we keep the sugar solution or salt solution undisturbed for some time, can you see any separation? Can you see separation means can they form any two separate layers? Can they form any separate layers? Not now. And what about in suspension? Definitely they form separate layers, like, you know, chalk down and water up. And what about in colloid, in milk? Can you see any such separation? No. That means solution and colloidal particles are stable. They are not settling. Not means they are not separating as layers. Solution and colloidal solutions are not separating as layers, so they are stable. They looks like same always, so they are stable, stability. But suspension forms different layers. Suspension forms separate layers. And what about the, you know, filtration? Can we filter sugar solutions? Can we filter colloidal solutions? No, but we can filter suspension. So these are the comparison between the properties. And solution particles are homogeneous, suspension heterogeneous, colloid looks like homogeneous but heterogeneous. And particle size, solution particles are too small, suspension not too small, suspension particles are big, we can see with our eyes. And colloidal particles also Too small we cannot see with our eyes, but colloidal particle size is between solution and the suspension. And third one, scattering of light. Solution particles are very small, so they cannot provide, they does not provide a surface for the scattering. So they do not scatter the beam of light. But suspension scatter the beam of light, and colloidal particles also big enough to scatter the beam of light. And solution and suspension stable. Solution and colloidal solution stable, because when we keep this solution sometime we cannot see any separation of the layers, but you can see that separation of layers in the suspension. And the filtration, we cannot filter solution and colloid, but we can filter suspension through the filter. You will get the chalk powder in the filter, in that filter, and water in the another beaker. Okay, then another very important term related to colloidal solution, colloidal solutions shows Tyndall effect. Colloidal solutions show Tyndall effect. Tyndall effect means what? It's very easy example. I just tell you. Suppose if you are lighting the torch through a hole to a dark room, when you send the torch light through a small hole to a dark room, can you see the path of light? You can see the path of light correctly, when you light the torch through the hole to a dark room, you can see the path of light clearly. So that process is known as Tyndall effect. When we send the beam of light through a hole to a dark room, the path of light is visible. So that visibility of the path is Tyndall effect. And the same you can see in the early morning. When you wake up early morning, you can see that the sunlight passes through the small gaps of the leaves. Okay, you can see that way correctly. Canopy of the dense forest. And in the early morning you can see that the path of light correctly when you look out. So that is Tyndall effect. Why these light, you can see that there is a lot of dust, water droplets, etc. outside. So when we send the light, these light strike on these particles. These light strike on the particle present outside, and after striking it returns back, and we see that path of light. So the presence of dust, dirt, moisture, etc. shows the Tyndall effect. So which solution shows Tyndall effect? Colloidal solutions. Okay, so let us conclude today's class. Pure substance is a substance which contains single type of substance. Mixture constituted by two or more pure form of matter. Two types of mixtures, homogeneous mixture and heterogeneous mixture. Homogeneous mixture is a mixture which contains uniform composition everywhere. Heterogeneous mixture is a mixture which contains variable composition everywhere. And then solution is a homogeneous mixture of two or more substances, and there are two components in a solution, solute and solvent. Solute is the component present in lesser amount. Solvent is the component present in higher amount. For example, in the salt solution, salt is the solute and water is the solvent. And in tincture iodine is the solute and alcohol is the solvent. Then we discussed about the suspension and colloid. Suspension is a heterogeneous mixture, and in suspension the solute particles do not mix, they settles down, and in colloidal solutions looks like homogeneous but they are heterogeneous. Then we compared their properties. Solution is a homogeneous and suspension heterogeneous. Colloid looks homogeneous but heterogeneous. Particle size is very small for solution, cannot see with our eyes. Suspension particles can be seen with our eye. Colloidal particles also cannot see with our eyes. And solution particles do not scatter the beam of light, but the suspension and colloid particles scatter the beam of light. And solution and colloidal particles are stable, but suspension is unstable, and we cannot conduct any filtration process in solution and colloid, but we can filter the suspended particles. That's all about today's class. Watch the video carefully. Try to understand the concepts. Have a nice day. Thank you for watching.